Given a binary tree, return the preorder traversal of the node's values. Suppose you have a tree that looks like this. We first visit 1. Since it has no left child, we go to the right. We visit 2, then we visit left child, which is 3. Since there's no right child, we finish. The result is 1, 2, 3. Recursive solution is trivial. Can you do it iteratively? A slightly more complicated example is this, where the result will be 1, go to left is 4, go left 8, go right 9, go left -4, and go up all the way where you are here, then go right 2, no left, then go right 0. So this is the desired result. Now the question asks us to do it iteratively. What is the difference between a recursion and iterative solution? Every recursive solution can be converted into an iterative solution. And the key is to understand what is recursion really. Because a recursion is just call stack. It's just the call stack is invisible to you. You are letting the recursion handling all the work. You are trusting the process. So instead of making call stack or recursion, we can declare our own stack, thereby converting a recursive solution into an iterative solution. So let's visualize this tree in our own stack. Now first, since we are given 1, we have let's assume this is the bottom of the stack. So we are pushing 1 onto the stack. Now, assuming this is our result array, once we push 1, we immediately pop it, so we get the result 1. Now we will push. Now here's the tricky part. Which child shall we push? Assuming we push the left child, then we push the right child, right? So this 4 is our left child. Then we push our right child. Then all of a sudden, when we want to pop our top element, the top element is 2. But wait a minute, since we're doing preorder, we should pop 4. So, we shouldn't push 4 first. That's why when we push, we should push our right child first, which is 2. So let's push right child. Then we push left child, which starts at 4. So this is what our stack looks like. Of course, I'm only writing the node 4. There's also 8, 9, -4 below. It's just a lazy typing. Okay, now we get a hold of 4. We can pop it. Now 4 is gone. We push the right child first, right? So the right child is 9, -4. Let's push 9, -4. Then we push the left child, which is 8, right? Just now we were at 4. Okay, this is -4. We were at 4. We push the right child, which is 9, -4. Then we push the left child, which is 8, right? Then the top of the stack is 8, right? So we pop it. So our result is 8. Since it does not have any right or left child, so nothing happens. We don't push anything. Then we are at 9. We pop 9. Then we push the right child, which does not exist. Then we push the left child, which is -4. Okay, now we are at -4. We pop it and push the result into our, and push the node value into our result array -4. Since it has no left or right child, don't push anything. Then we are finally at this 2, 0. We push the node value into the result array. We pop this guy. We push the right child, which is 0. Left child does not exist. Then finally we push value, node value to the result array. We pop him. No right child, no left child. Our stack is empty. Finish. So we have our result, which is the same as the desired result. So let's code it out. I will now code it out in C++. Later I'll go over the solution in JavaScript. First of all, let's declare a result array. Let's declare a stack. Notice we are putting node data structure into the stack instead of integer. We first push the root onto the stack. If our stack is not empty, we keep the while loop. Now we get a hold of the top element of the stack. Then we pop it immediately. Right? Because now we already get a hold of the top element, so we can just pop it straight away. Now, if our top element is a null pointer, let's continue. Else, our result array should push the node value. Also, we push the right child first to the stack. Then we push the left child. I believe this will work. Let's submit and see what happens. Okay, so let's do JavaScript. JavaScript is very similar, so let's not reinvent the wheel and see what we have here. So we have a stack and the result. Since in JavaScript they are the same, both of them, because JavaScript does not have a stack. So we are going to use array. Then we push, stack push, right? Then not, let me just copy this guy. Let's change while stack.length, while stack is not empty, we get a hold of the top element. Yeah, let me just use the word stack s to save some typing. S.length -1. This means the same as, whoops, as this, right? Stack pop. If not, well, let's use null. This will be push dot. This will be dot. I believe this will work. All right, so there we go.